Good morning friends. Today we are going to see a simple point-to-point network connected between two nodes. So there is a node N0 and there is a node N1. Between these two nodes we are going to have a physical cable which have a bandwidth and a delay factor. Okay. So after that we are going to find out the network animation, how the packets are exchanged between them, and we are going to compute the throughput of the particular complete network throughput. Then we are going to find out the plotting solutions also. So everything we are going to find. And here's a problem statement for the laboratory experiment on P2P network.
Good evening friends, welcome to Engineering Clinic. In this video today we are going to see this statement on point-to-point networking. So the question here is, design two wired nodes that can connect to each other through a point-to-point network that handles the data rate of 50 Mbps and a delay of 5 milliseconds. The first node acts as a server and the second node acts as a client, and they exchange at least 10 packets in a total simulation time of 20 seconds. The maximum packet size is 1024 bytes and 512 bytes. Plot the throughput of each nodes for the above packet sizes. Use any charting solution you are comfortable with. So this is one of a laboratory experiment for NS3 which I am going to explain you now. So the source code along with the methodology to run everything I am going to explain you now. So I am going to take the example of first.cc file, so which is available in the examples tutorial folder. So ns-3.38/examples/tutorial. So in this folder I have this first.cc file. So this file I will be using it. So to start with, move the above file or copy the above file. So copy the above file to scratch folder. So scratch is here. So 3.38. So you have to move the file to the scratch folder. So first what I do is I'll just go to the browser window and NS all-in-one 3.38, then NS 3.38, then examples, then tutorial and first.cc. So this is the file. So Control C, I am just using Control C, then back and move to scratch. Inside the scratch I am pasting it here. Now this way I have just done. Now I open this file. Now this is the file I am going to use. Now this is how the way the question is asked. So N0, N1, and this is a point-to-point network. So 10.1.1.0. This is an IP address, ranging is given. So to explain you the source code, I already given my given a video in my channel on explaining first.cc file, but I'll briefly explain it again. So first, anytime we will be using namespace NS3, using namespace NS3, which is similar like using namespace std when we do in a general C++ programming. And we create a main function. In the main function we have argument count and argument vector. So these are the arguments. So why we need an argument count, you can able to check that in the second.cc file. So now the resolution time is on nanosecond time resolution. So for that we create a class here. This set resolution belongs to the time class. That's why we time scope operator and set resolution. We are going to use an application called as UDP echo client and UDP echo server application. So the server will be echoing the number of packets and the UDP will be receiving those packets. This is what we are going to do. Now the node container is the name of a class that creates a node object, then nodes.create 2. So totally we are creating 2 nodes. So within these 2 nodes we want to create a point-to-point helper class. So we create an object name called as point-to-point. So point-to-point.setDevice attribute, the data rate is 5 Mbps it's given. So now what I am going to do is I am going to use 50 Mbps here. So as per the problem statement I am going to use 50 Mbps. So let me change it to 50 Mbps. Then the delay is, I am going to use a delay of 5 milliseconds, which is given here as 5 milliseconds. So this I am going to use as 5 milliseconds. Okay. So now we have once we have set the node, then we have created the point-to-point helper class. Then we are going to create a net device container. So net device means it's this is the place where we can able to set the IP address. We can able to set the hardware and the software for a network interface card. For that we create an object called as devices. So devices equal to point to point dot install on these nodes. So nodes is a variable, this is the variable here, nodes. So there we are going to install the point to point helper class in this. Okay. Now after that we want to give network connectivity to both the nodes N0 and N1. For that we create one object called as internet stack helper. We want to establish network connectivity or internet connectivity for all the nodes. So now again install these things in the nodes, that is the stack.install nodes, install this. Next thing is we want to set the IPv4 address. So we can able to set IPv6 also, but in this example I am just telling you only on the IPv4 address helper. So create an object called as address. Now first we are going to set the base address. Base address means 10.1.1.0. So now you can see that this 0 means this is the first address of the network. So usually 0 will not be allocated to any single computer. It is called as a network address. So we set the base address here and the masking is given here 255.255.255.0. Then afterwards create an interfaces and assign this IP address to all the devices. So device is a variable name already we have created as a net device container. Now assign each and every IP address to these devices. So that means any number of nodes when you create, all these IP addresses will be allocated automatically by NS3. So now in this case we have two nodes. So one node will be 10.1.1.1, another node will be 10.1.1.2, that will be allocated. Okay. So now we have created the node, we have created the channel, we have created the net device container, we have created the internet network, we set the IPv4 address, and we create the interfaces also. Now our application. Now in this application we have UDP echo server helper echo server. So the name of the echo server, and here the port number is 9 is given. Port number, in case we have a doubt I can give it as 8080, port number 8080. Now application container server apps echo server dot install nodes dot get one. Now who is the server and who is the client? Now as per this program I said that the first node acts as a server. That means the first node will be the server. First node is presented as this way. So this is the first node. That means nodes dot get of 0 is the first node. Is the first node. I'll use the commenting line here. And the second node is nodes dot get of 1 is the second node. So these are the two things that we can able to set up on. Okay, so now what we do is, so the node of get 0 is a server, so I'll make it as server here. So it is 0, that is a server. Okay, so first the echo server, I am setting the node 0 as the server, and server apps I am starting the server at 1.0. As per the time simulation I have given as 20 seconds. So 20 seconds they want to exchange packet. As per this program I ask them for 20 seconds. Okay, so then I am going to set the UDP client helper. So in the UDP client helper they wanted to exchange 10 packets with each other, between each other. So I am creating as 10 packets here. Here it is given as 1 packet. I am going to create 10 packets. Now echo client will be the get address of 1 here, interfaces dot get address. So who will be the client that we are going to do now? The client is 1 here, and the port number is 8080. So instead of 9 we have created to 8080. This is a port number. Now total number of packets is 10. And now the thing comes up here. The maximum packet size is 1024 bytes and 512 bytes. So you have to do two simulations. One simulation with 1024, another simulation with 512 bytes. So that we will do that. Now by default I have 1024 here. Now application container. So I am going to create node nodes.get1 means that is a second node. So this is a second node will be the client. Okay. So the client will be starting from 2 to 20. So this 20 seconds we have read. So no, but we need to plot the throughput characteristics. So what we do is we have to write the code here for ASCII trace. We have to write the code. So ASCII trace helper ASCII. So this one line we have to write it. Then afterward ASCII trace helper ASCII. Then we'll create an object here. So this object is this is an object. We are going to establish the ASCII for this point to point channel. So in this what we do is point to point channel dot enable ASCII all, then ASCII dot create file stream. So we are going to redirect all this information to 1024.tr. the trace file we are going to write everything here. Now these are the two lines we can able to do it on a ASCII trace helper ASCII. So this is for ASCII trace. Now this is for NetAnim. NetAnim is I want to use animation interface anim. I want to create a file name called as p2p.xml. I want to create this file name. That's it enough. p2p.xml I can give. So for animation to work, we have to include a header file. So the header file is given like this: hash include ns3/netanim module.h. So this file we are going to include it here. So now network animation is done, and ASCII trace is also done. But in case if we want to establish pcap also, we can use here pcap or Wireshark. This also we can able to use here. So for that what we can do is okay. So NetAnim and ASCII trace both we have written. So now we are going to run this simulation for 2 times. Okay, so now here to run this file, let's open a terminal. So cd ns all-in-one 3.38/ns 3.38. Then the command is as simple as to run. So /ns3 run scratch /first.cc. So this file we can run it and change the 1024 to 512 as packet size, and change 512.tr in the trace file and compile it again. So you have to do the 2 times compilation. So first time will be like this, and second time one more time you have to do the compilation like this. So we have to get 2 files.
So we are going to now run the example, that P2P example. So cd ns all-in-one 3.38/ns 3.38, then /ns3 run. We have the file in the scratch folder. The name of the file is first.cc. So once we run it, you can see that the output we got it here. So but the client is sending, the server is not sending. So that means we need to edit the file again. So scratch first.cc. So when we edit it, so we can see here, and this change. So we have to give get address of 0. The first address of 0 we have to give it. Okay, now we'll run it again. When we run this, okay, you can see here now. So at 2 seconds the client sent the bytes, and then 2.0051 seconds server received it. At the same time server also sent one more 1024 bytes, and the client received 1024 bytes. So this way that 1024 bytes simulation we have just done it. Now we have to do the same process again for the 512. So now we can check it here. We got one file called as 1024.tr is created, and p2p.xml is created. We will see how that network animation can be viewed, but now we will go for creating the 512. So again we will open this file for changing that 512. So now instead of 1024 we use 512, and instead of 1024 here we change it to 512. So a very simple logic here. So we have this thing 512 and this 512. Okay, so now we'll be running it again. I'll clear the screen and I'll be running this again, this first.cc. Yes, you can see, but here it doesn't mention anything about the throughput. Here we have to calculate the throughput. Okay, now click this ls. Now we got 2 files. One is 1024.tr, one is 512.tr, and we got the p2p.xml file. So p2p.xml file is only one file that can be run using the software called as NetAnim. So for NetAnim, Again, you can open new terminal or you can directly come here. So NS all-in-one 3.38. Inside this folder, we have something called as a NetAnim. So inside this all-in-one, we have NetAnim is one package, NS 3.38 is another thing. So we are going now with CD NetAnim. So once you go here, click ls, you can see there is one green color file, this file NetAnim. You can see N is uppercase letter, A also uppercase letter. So what we have to do is we have to run this example like this /NetAnim. So / means the current folder. In the current directory, we have one executable called as NetAnim. Execute that, run that. That's what it means. So once you open it, so this NetAnim, just open this file in the top left, then go to NS all-in-one, NS 3.38, and we got the file called as p2p.xml. So just open this file. So once you open this file, you can see that we got these two nodes. So to make it bigger, you can make it to the node size number 5. And if you don't want the grid, you can disable the grid. So you got this screen, so 0 and 1. So there are two nodes here. Now here there is a simulation button here, so the play button. So once you start playing it, you can see that the packet exchange is happening here. So since we have given 10 packets, so every time there will be for one exchange there will be 4 packets, because client is sending, server is sending back, and client receiving back. So you will be getting the time frame. So you can see the timer is running here 5 seconds now. Likewise, up to 20 second simulation we have done it. But before that, if the packet exchange is completed, then the complete simulation gets over. So this is just for checking whether the code is working or not. For that we use something called as a NetAnim. So network animation or animator. Okay. So this thing is done. So now our main part is that in our question what we have created is we are assigned to run the P2P. I'll open that file. Yes. So now in this example, what we have to do is we have to plot the throughput of each nodes for the above packet sizes. So we have to plot the throughput. So in that case, what we have to do is we have to run the example. So now here we are going for another software called as Tracemetrics. Okay. So this we have done it. Then open another terminal and go to cd ns all-in-one -3.38 / NetAnim -3.109 / then /NetAnim. So once you do that, open the XML file and then check the output in the animator window. So now next is to find the throughput with the help of a software called Tracemetrics, which is already installed. So check the video in my channel for installing Tracemetrics. So that's what. Now again open another terminal or use the existing terminal. Okay, so now what you do is cd and put enter, then cd Tracemetrics. I'll show you now. So open another terminal. Let me go into the next terminal. So cd Tracemetrics. You can see that this command. So cd Tracemetrics. Then we go with the java -jar tracemetrics.jar. So this command we can run it. So java -jar tracemetrics.jar. So once we run this command, a window gets open like this, and this is what the trace analyzer, a trace analyzer for NS3. So now click file, choose file, and go to the location of NS all-in-one 3.38, then NS 3.38, and we have two files 1024 and 512.tr. So now 1024 I am just opening, execute analysis. Once I do the execution, we can see that how many number of lines on the file, all this thing is there. So now the throughput here is the throughput and the goodput, we have two things. So in this example we ask only for the throughput, but maybe just control C, right click and copy, or control C, then come to the editor window, and for 1024.tr, here is the throughput. Okay, so the 0th node the throughput is this, the first node the throughput is this, and this value is a goodput, so goodput is not needed. So now, so we will remove the goodput. Okay, so in case if you want to use only two decimals, you can use that. This is for 1024. Similarly for 10512 we can able to see. Apart from that, we have other results also here, but in this question we have asked only for the throughput. But if you want to plot any others also, you can able to plot it here. So again I'll go with file, choose file, I'll go with 512.tr, execute analysis. Once it is done, now when you come to the throughput here, so these are the things here. So now what we do is for 512.tr, this is the throughput. So from here to here I will just delete that. Okay, so 0 for 957 and 1 957 and 0 for both are same. So for only, since there is only two nodes here and we have a bandwidth established between these two nodes, this is what we are expecting. But if you have more number of nodes, you can able to really find the throughput well and good, and we can able to find the average throughput also will be varying drastically. So when the number of nodes are a different kind of network and different kind of nodes, different types of nodes like that, so the throughput might vary. So since it is a simple network, this is what the throughput we got. Now we want to plot this. So we have 0 1, so node number 0 1, and for 1024 and for 512, so we can able to plot like this. So maybe I'll just open one charting solution called as, I'll go with the Libreoffice. So since it is Linux, I am going with the Libreoffice. In case if you want to use Gnuplot, you can able to use Gnuplot. Okay, so what you can do is, so 1024 is, so sorry, 512 1024. So these two things, click a new insert rows above. So this is throughput, and here node 0 n0 n1. So for 512 the value is 492.27. For here 957.28. So when you plot, insert chart here, so you insert a chart, and in this chart either you can give, you can see here even throughput for 512 it's there like this, and this is for this. So throughput, yes, if you want to go with the Gnuplot on this thing, you can able to do the different things on a Gnuplot. So what you can do is, we will have these things. I will just copy this thing in a new file. So 0 and 1, so these two things, and let me close this window, and 957.28 492.27. so I will copy this. So let's say I will go with the Gnuplot. So this thing and this thing, so here this will be 492.27. so 492.27 and 492.27. so this is what throughput, thro throughput.txt. I give the data name as throughput.txt. I have just given here. Now I am writing one more file called as control as gnu.plt. plt is the plot file. I am going for a plot file here. So what I do is set terminal PDF. So I am going to create a output of a PDF file. Set output, the name of the PDF file is throughput.pdf. Then set title, I am going to give as throughput versus um, packet size. So this is what we are going to do it. Now set x label is packet node. X label, I can say that node number, and set y label as throughput in bits per second. Okay, so then plot, we are going for through throughput.txt using 1:2. 1:2 means first column and second column with lines points. So title is it's 1024 as 1024. Okay, comma, again through throughput.txt using 1:3 with lines points, title 512. So these are the two things. So this is a simple thing here. So terminal PDF means I am going to write the output in a PDF format, the name of the PDF file, and the title in above the graph, then the what is the x-axis and what is the y-axis, and that the plot is a command, and the command I am going to use the throughput.txt file. So from this file I am going to 1:2 means one first column and second column, and first column and third column. So column number 1 is common with both the graphs. So now I am going to run this example. Now as usual, I go to this terminal, put cd and enter, then Gnuplot, put the code gnu.plt. So this is the name of the file. So once you do that, no errors, then we go back to this. You can see that we have the file throughput. So throughput.pdf. Now yes, this is what generated. Now when you see the throughput.pdf, so you can see here, so one line is we got it here, so you can see the pink color line, the another line we got it here, so the green color line. So this is the throughput that what we got in the each and every node. But if you want to take the average throughput, so take the average of all the values, then you plot it. So that way also you can able to take the plot. So you can see that now this is the title, and this is the y-axis, and this is the x-axis. So that's what the file we got generated. So hope you understand this, how to plot it. But the plotting is, you can able to do different method of plotting. I use this method. You can use any other tool like Microsoft Excel sheet or Libreoffice or whatever tool you like, you can able to do that. So thanks for watching this video, friends. So subscribe to my channel and share it to your friends also. Thank you.